Alright guys, this is for all classes now. This is sort of the last 3 problems that I had for you to work on today. So hopefully both classes, I think we're pretty close to this. So I apologize, period 1, 2. If you guys had already done this one, sorry. You can fast forward to this one maybe. But here's what we got. Same situation, the external times the entire. So it would be 4 times 13. And then the bottom one would be 5 times 5 plus x. And if you solve this, I think it gets a little bit messy here. You get, what, 25 plus 5x, 4 times 13, that's 52. Subtract the 25 from both sides and divide by 5, and you get a nice, beautiful fraction. So 5.4 or 5 2/5 if you want to keep it in a fraction form. And you look at this one. This one's pretty close to drawing to scale. I'd always do like a sanity check and look. Your book is pretty good about drawing to scale, better than Mr. Hesp certainly. 5 2/5. This looks about the same. Looks maybe a little more. Certainly looks a lot less than the 9 on there. So it sounds reasonable to have that length on there. These last 2 are just beautiful because of the presence of some quadratic relationships. So you're going to get, when you set up your equations, you're going to get some that are quadratic on here. So give you a second to try these out. Good time to pause and just know you're going to get quadratic, you're going to have to factor. I'll just tell you that sort of up front. Be ready for it. Pause, go for it. When you're ready, here we go. So it should be 4 times 12. Of course, that's 48. And then down here is x times this entire length of x plus 2. Here's where my quadratic comes in. X times x is x squared. I get 2x. We already said this was going to be 48. And then, of course, I'm going to have to move the 48 to the left side, which I've already done that here. Hopefully that step didn't throw you off on there. So all I did is distribute, swing the 48 over. Now I'm ready to factor this thing. Think of your factors of 48. That's not too hard. They're in your times table that have a difference of 2. And, of course, you come up with 8 and 6. Think about your signs. You want them to add up to be positive, which means the bigger one would have to be positive. And again, those are my factors. It gives me 2 solutions. This solution for this root would be positive 6, and this one would be negative 8. And I'll tell you, sometimes the negative works. In this case, if you plug a negative length in here, that doesn't make any sense. It would not work. So we keep the positive, toss out the negative, and we know that has to be 6. Now if you look, yeah, it looks reasonably drawn to scale. This looks more than that. 6 times 8 is 48. Of course, that we're verifying this whole thing would be 8. And of course, 4 times 12 was 48, so it works. When you try the last one here, one question to be thinking about, you might ask, why was it labeled like this? Think about how long that green segment is. On the screen it's green. You can't tell probably because of the recording on here, but that entire length is 8. So when you get your answers for this, whatever you get for this and this, better add up and equal 8. If you were to add 8 minus x plus x, the x and the negative x would cancel and you get 8. So this length better be 8. Of course, this one's 7, so it kind of looks reasonably drawn on there. So this is a review of the previous page if you forgot. Flip the page over. It's 4 times 3, and it's x times 8 minus x. This is just this chords relationship. So here's where the quadratic comes in. 8x and negative x squared. And on this side, of course, we get 12. And we should get it all on the same side, which means you subtract the 8x over, and you add the x squared to the other side. That's what it would look like if it was all on the right side. And it's factorable, oh yeah. Factors of 12, that's summed to negative 8. Of course, you're thinking 6 and 2, and you hopefully realize they're both negative. So x minus 6, x minus 2 gives you 2 solutions. And you plug them back in and verify if they work. So if you were to plug in, and I would say one of these, if we're really thinking geometry, and if this is drawn close to scale, only one of these answers really makes sense. Now, if I said it's not drawn to scale, either answer is okay. Think about which one of these answers is much better in terms of the scale of the drawing. If this was 6, if I plug in 6 here, I'm going to get 8 minus 6, which means this is 2. And if this is 2, I plugged in 6 here, that wouldn't make any sense because this is clearly shorter. So x being 6 doesn't really make sense. I mean, I'm going to circle both of them because algebraically they both make sense. If the drawing's not to scale, they both make sense. But I want you to think a little more about that. 2 makes a lot more sense on here. This is 2. Plug in the 2 here, you get 8 minus 2, you get 6. And like I said in the beginning, this whole thing should be 8. So these are the two different values basically of this one and this one. So again, the 2 makes a lot more sense because of this. If we say the scale is a part of this drawing. So if this was on a quiz, you're probably asking, well, what would this be like on a quiz? If I wrote the drawing is to scale, you better realize it's 2. If I write the drawing is not to scale, or and usually I don't want you to assume the drawings are to scale, either answer would be valid on there. You know, either length could be valid. If you're checking those homework problems, check your odds in there. There is a worksheet I want you working on today. I'd like to throw these up here for you. I don't care if you can see the answers. Oops, sorry. I don't care if you can see the answers. Check your work. Take a few minutes at the end, or certainly you can delete it, or so you can pause this, come back to this later. And some of the answers are cut off on the bottom, but that's all right. They're both odds anyway. So here's what they should look like. Go for it. If you have questions, I'll be in on Friday. You're going to have to take a quiz on Thursday on these 2 sections, so I strongly recommend you talk to Mr. Snyder. He's as much an expert in this stuff as anybody else. He certainly can help you. He knows these theorems very well. So if you have questions on why these answers look crazy or mad to you, speak up, ask him. The quiz will be short on Thursday. It's not going to be a long quiz. So be ready for it. It's going to cover the last 2 sections we've covered. So everything that's on this, as well as the things from 11.4. So there's 4 or 5 theorems on there, 3 or 4 theorems on there. I think it's 5 theorems total, 6 theorems total. So be ready for it. But again, it's focusing on those 2 sections. So enjoy. And if you stuck around, here's the answer key for 11.5. I don't care if you have it. There it is right there. I'd love to see you get a chance to check those out. Those of you that are patient, you watch movies and you always stay till the end of the credits, this is for you guys. You might be one of those people. There they are. Enjoy.